Hello everyone, welcome to the next lecture on mathematics. From this video, we are start the Fourier series. We will discuss the many example important question. And in this video, we will discuss the Euler's formula, that is Fourier series formula, and important example. If you have any doubt in Fourier series particular question, you can send your question in Telegram group. Link of Telegram group is given in the description box or send in a comment section. In the next coming video, we will discuss that particular example. Now, Fourier series having many application in engineering. If we discuss the conduction of heat, so that topic contain the Fourier series, also electrodynamics, और sometimes we listen the music और उसके कुछ beats हमें अच्छे लगते हैं. Why? Because of certain pattern is there. So उस sound के अगर हम pattern को अगर curve के form में express करेंगे तो you will get some wavy curve. So that wavy curve or any square curve that we can write in a summation of sine and cos, or any periodic function again that can be expressed in a sum of sine and cos. So in short, sometimes we get a certain pattern of wavy curves and certain periodic terms. So that periodic function we can express in a simple sum of sine and cos. That is nothing but a Fourier series. So especially the Joseph Fourier studied some heat conduction, and that time he get the idea that we can express any periodic function in a sum of sine and cos. और वही से क्या आ गया फोरियर सीरीज. तो बिकॉज ऑफ जोसेफ फोरियर उसी के नेम से हम उसको फोरियर सीरीज कहते हैं. Joseph Fourier is very talented from his childhood. He is interested in the mathematics, and he has faced many challenges in his life, including losing his parents at the young age. When he was the 9-year old, he lost his parents, and but the Joseph remained focused on his study, and he was determined to pursue his passion in the mathematics and science. So let's start with our today's topic. As I told you that Fourier series is applicable for periodic functions. So first we understand what is a periodic function. So periodic function means what? Sometimes we get the value of function repeated when we put the value of x. So certain time the duration the values will be repeated. For example, if we consider the function f of x is equal to sine x. Now, when we draw the curve of this sine, so you will get this type of curve. Let's suppose this is our x-axis, this is a y-axis, 0. Now, if we draw the curve of sine, so it is a wavy curve, and in this way you will get that curve. So what will happen if sine 0 is 0? So after pi you will get again sine is 0, then after 2 pi again you will get the 0. Here sine pi by 2 it is value is 1, but when we add the again continue with this process, so sine 3 pi by 2 is minus 1, and continue with, if we continue this curve, so again you will get the 1 and then again minus 1 again 0. So this type of curve you will get, and this nature of curve is nothing but a periodic. So here sine f of x equals to sine x, and if we add, suppose we take the addition of x plus 2 pi, so x replaced by x plus 2 pi, so here it is a sine x plus 2 pi, and find the value of this term. So if we apply sine a plus b formula, so the formula of sine a plus b is sine a cos b plus cos a sine b. Now apply this formula for this term, so you will get sine x cos 2 pi, then plus cos x sine 2 pi. But the value of sine 2 pi is 0 and cos of 2 pi is 1. So if you put cos 2 pi is 1 and sine 2 pi is 0, so this second term is completely 0, and here first term remains is sine x. But sine x is nothing but our f of x. So f of x plus 2 pi is equal to f of x. Now, in case if I will add again 2 pi, So here f of x plus 2 pi, again add the f of x plus 2 pi plus 2 pi, so it become a 4 pi. And if you simplify this term, so again you will get the sin x. If we again add this term x plus 2 pi, so 4 pi plus 2 pi, it become a 6 pi. So continue this adding the 2 pi, again you will get the same answer, that is a sin x, that means f of x. So here we can say the value of function is repeated after 2 pi. So the period of this function is 2 pi. So when we add the 2 pi, their answer remains same. So function giving the repeated value, so it is called a periodic function. And certain constant, when we are adding that constant, fixed constant, and then we will get the same answer. So that constant is called a period. So that means here when we add the 2 pi, 2 pi, 2 pi, so there will be no change in the answer. So we can say sine is a periodic function of period 2 pi. So period of this function is 2 pi. Now in case if we consider cos x, so cos x, again you will get the same wavy curve, a little bit of different values, but you will get the same type of wavy curve. So for cos, if we draw the graph, then for cos 0 is 1, and if we draw the curve, so in this way you will get a curve. So observe this graph at fixed time, you will get the repeated value. That means here cos 0 is 1, cos of pi by 2 is 0, cos pi is minus 1, cos of 3 pi by 2 is 0, and again here cos 2 pi is 1. So here cos 0 is 1 and cos of 2 pi is again 1. So 1 is repeated after 2 pi. So that means here again if we add 2 pi in the function, so you will get the same answer, that is a cos x, and that is nothing but f of x. So again here f of x is equals to f of x plus 2 pi equal to f of x plus, again add 2 pi, so it become a 4 pi. Continue this process, so you will get repeated value, that is cos x, cos x. So we can say cos x is again a periodic function, and this period of this function is 2 pi. So the definition of periodic function is a function f of x satisfies the relation f of x plus nt equal to f of x, where n is 1, 2, 3, and so on up to infinity, and t is a positive constant, is called periodic function with period t. So a function is called periodic function with period t. If we add t any number of times, still we get the same answer as f of x. So this representing f of x equals to f of x plus t, f of x plus 2t, 3t, because n is our 1, 2, 3, and so on. So n can take any value from 1 to infinity. As we have taken in this function 2 pi. So see here, if we add 2 pi in a function, we will get is same as f of x. 2 pi you can add any number of times. So here f of x plus n times 2 pi, you will get the same answer. Next we see Fourier series. Firstly, I will tell you most general form of Fourier series. So here, the Fourier series for function f of x in the interval c to c plus 2l. Here 2l is nothing but a period of this function. Now see here c to c plus 2l. If we find the length of this interval, so length of this interval is 2l. So here interval length is 2l, that's why we can say 2l is a period of the function. So function we are discussing that are periodic function, because we know that Fourier series is applicable for the periodic function, and the period is 2l. So Fourier series for the function f of x in the interval c to c plus 2l is f of x equals to a0 by 2 plus summation n varies from 1 to infinity a n cos n pi x by l plus b n sin n pi x by L. And here C is constant. You can take C is 0, L is 1. So you will get interval 0 to 2. If we take C is minus pi, L is pi, so you will get interval minus pi to pi. So इस formula की help से you can form the any but special type of Fourier series. Now, how to find this A naught, A n, B n? So here A naught is 1 upon L integral. Here interval is c to c plus 2l. So you have to take integral from c to c plus 2l f of x dx. So our given function here we have to integrate from this interval c to c plus 2l. And an, see here an multiplication contain cos. So in the integral also 1 upon L integration c to c plus 2l f of x into cos n pi x by L dx. Similarly, Pn is 1 upon L integral c to c plus 2L f of x sine n pi x by L dx. Same as An. So here An into cos, that's why integral contain cos. Bn into sine, so here we are taking f of x into sine. और यही फॉर्मूला अगर आप याद रखते हो तो अदर कोई भी फॉर्मूला आपको याद रखने की जरूरत नहीं पड़ेगी. दिस इज द मोस्ट जनरल फॉर्म. तो यू कैन पुट सी और एल एज पर द क्वेश्चन, यू विल गेट द आंसर. Now, what is this A0, An, Bn? This A0, A1, Bn is nothing but the Euler's formula. So ये जो हम Euler's formula की बात कर रहे थे, तो A0, An and this Bn is known as are known as Euler's formula. Euler's formula. Now, इसी general form से I will tell you the one particular example that how to use this Fourier series to find a particular formula of Fourier series. We want Fourier series for interval 0 to 2 pi. Now this 0 to 2 pi, if we compare with our general form of interval c to c plus 2l, because we know the formula for c to c plus 2l. So compare this term, so you will get the idea. C is our 0 and 2l is 2 pi, that means L is pi. So therefore, f of x is a naught by 2, a0 by 2 plus summation n varies from 1 to infinity an cos n pi x by L. So by L means here L is our pi and this pi get cancelled. So formula will become a cos n x plus bn sine n pi x by L. So L is our pi. So again here pi get cancelled. So that means it is a0 by 2 plus summation n varies from 1 to infinity an cos nx plus bn sine nx. So for 0 to 2 pi, angle is nx. So pi will cancel. That's why we will get this term. Now how to find a naught? It is 1 upon L, but value of L is pi. So 1 upon pi integral 0 to 2 pi f of x dx. 1 upon L, so L is again pi. 1 upon pi integral 0 to 2 pi f of x into cos. So cos, this term is cos nx. So we have to take cos nx dx. And for Bn is 1 upon pi integral 0 to 2 pi f of x into sine nx dx. So this is the special formula for the interval 0 to 2 pi. See, suppose we want Fourier series for the interval minus pi to pi, because maximum time when we solve the question, that time we either get the interval 0 to 2 pi or minus pi to pi. Sometimes you will get the interval from 0 to 2, some constant form minus 2 to 2. So that again we will discuss, but these are the two most useful formulae when we solve the question. Maximum time they will ask you 0 to 2 pi or either minus pi to pi. Now see this formula here again. This interval I will compare with our most general form C to C plus 2L. So compare this term. So you will get C is minus pi and C to C plus 2L. So C plus 2L is pi. Put the value of C minus pi, and if we shift this term, so here minus pi plus 2L, 2 pi equal to 2L. So it is 2 to get cancelled. That means L is pi. Therefore, the Fourier series for the function f of x is, first term is a0 by 2 plus summation n varies from 1 to infinity an cos n pi x by L. So what is the value of L is pi. So again this pi get cancelled, plus bn sine n pi x by L. So L is pi. So this pi get cancelled. That means it is a0 by 2 plus summation n varies from 1 to infinity an cos nx plus bn sine nx. Now only change is here when we solve the a naught, that time we have to take integral from minus pi to pi, because here interval is minus pi to pi. In interval 0 to 2 pi, integral is 0 to 2 pi. So here a0 is 1 upon pi integral minus pi to pi f of x dx, and an is 1 upon pi integral minus pi to pi f of x into cos nx dx, and bn is 1 upon pi integral minus pi to pi f of x into sine n pi nx dx. Now, when the integration limit is minus pi to pi minus a to a, that time we use the concept of even and odd function. उसमें क्या होता है, when we know that even and odd concept, तो वहाँ पे a0 an bn ये तीन कांस्टेंट ना निकालते हुए only we have to find either a or b, but there is a condition, तो वो condition समझ लेंगे, then after that we will start using that even and odd condition. How to check even odd, how to apply that term, or where we can apply the even and odd, that everything we will discuss in the coming video. So I hope these formulas are clear. So let's discuss the example. Here question is, obtain the Fourier series for function f of x equals to e raised to the power minus x in the interval 0 to 2 pi. So in a question, the given function f of x is e raised to the power minus x in the interval 0 to, here it is 0 less than x less than 2 pi. That means it is open interval 0 to 2 pi, but when we solve the integration, so whatever they are not equal to, but still when we integrate, we are including this 0 and 2 pi also. So here interval is 0 to 2 pi, that means Fourier series formula for function is a0 by 2 plus summation n varies from 1 to infinity an, and for 0 to 2 pi cos angle is only nx, plus bn sine nx. Now find one by one this constant. So I will call this equation is equation 1. So a naught is 1 upon pi integral 0 to 2 pi f of x dx. Put the value of function. So 1 upon pi constant as it is, integral 0 to 2 pi f of x is e raised to the power minus x dx. Integrate this term. So 1 upon pi as it is, integration of e is e raised to the power minus x divided by coefficient of x is minus 1. Integral is 0 to 2 pi. Put upper limit minus of lower limit. So here Minus 1 is constant that we can take outside. So minus 1 upon pi is as it is. If we put upper limit is 2 pi. So it is e raised to power minus 2 pi minus of lower limits e raised to power 0. That means it is minus 1 upon pi outside term as it is e raised to power minus 2 pi and any number raised to power 0 is 1. So e raised to power 0 is 1. So therefore I will just multiply this minus sign inside the bracket. So it is a 1 minus e raised to power minus 2 pi divided by pi. So this is the value of our constant a0. So माइनस साइन जस्ट बाहर था तो इसको ब्रैकेट में मल्टीप्लाई किया सो दैट वन negative है it become positive and this positive term become negative. So 1 minus e raised to power minus 2 by pi. So this is our equation. Let's assume that it is equation number A. Similarly, find an. So formula of an is 1 upon pi integral 0 to 2 pi f of x into cos nx dx. So here function is e raised to power minus x cos nx dx. Now here both e and cos contain x, but you cannot use the integration by parts formula because both are going continuously derivative or integration. Now here to solve this term we have to use the formula. That formula we always use when we solve the Laplace also. So Laplace transformation में भी ये formula मैंने बता दिया था, but जिन्होंने नहीं देखा I will rewrite this formula. Note down the formula. Integral e raised to power ax cos bx dx is e raised to power ax upon a square plus b square in bracket a cos bx plus b sin bx. So इस फॉर्मूले की हेल्प से हमें इंटीग्रेशन को सॉल्व करना पड़ेगा. So therefore an is 1 upon pi as it is, or integration of term is e raised to power minus x upon a square plus of b square. So it is n square. So see here a is our minus 1 and b is n. Compare the power of e and angle of cos, so you will get idea. Coefficient of x in the power of e is a, so a is minus 1 and b is n. In bracket a is minus 1 cos nx plus b, that is n into sin nx. Now put upper limit minus of lower limit. When we put upper limit in sine, so sine of n pi and sine of 0 both are giving the answer 0. So sine n pi is 0 and sine of 0 is again 0. So that means when we put upper limit minus lower limit in this last term, so for upper as well as lower, both term we will get a 0. So no need to put in this last term because ultimately it is giving the answer 0. So here put upper limit minus of lower limit in this first term. So upper limit is pi. Upper limit is 2 pi. Put x equals to 2 pi. So e raised to power minus 2 pi divided by 1 plus n square into minus cos 2 pi n. Minus of lower limit x equals to 0. So e raised to power 0 divided by 1 plus n square minus cos 0. Simplify this term. So cos of 0 is 1 and cos of 2 pi n is minus 1 raised to power 2n, and when we multiply by 2 to it become even. So for even power it is a plus answer. So therefore here an is 1 upon pi as it is, e raised to power minus 2 pi divided by 1 plus n square, and this term is 1 and this outside minus, so it is minus 1 minus e raised to power 0 is 1. So minus 1 upon 1 plus n square cos of 0 is 1. So from this bracket, take the common term outside. So 1 upon pi 1 plus n square we can take outside. And if we simplify this term, so this minus of minus plus, so this second term is plus. So I will write plus term 1. Here minus into e, so it is minus e raised to power minus 2 pi. That means value of an is 1 minus e raised to power minus 2 pi divided by pi 1 plus n square. So this is the answer of an. Let's suppose this is equation number b. Similarly, if we find bn, bn is 1 upon pi integral 0 to 2 pi f of x into sine nx. bn is 1 upon pi integral 0 to 2 pi, put the value of function e raised to power minus x into sine nx dx. Again here we have to use the formula. So formula is integral e raised to power ax into sine bx dx is e raised to power ax upon a square plus b square in bracket a sine bx minus b cos bx. So in the formula of sine, if middle term is minus sine, so minus b sine cos bx. So using this formula here, bn is 1 upon pi as it is. It is e raised to power minus x upon 1 plus n square. A is minus 1. Here again compare the term. So a is minus 1 and b is n into sine nx minus b cos nx. Again, if we put upper limit minus of lower limit in sine, so this term is 0 for upper limit as well as lower limit. That means only we have to put upper limit, lower limit in a cos term. So therefore, bn is 1 upon pi as it is. Put the upper limit e raised to power minus 2 pi divided by 1 plus n square. Here minus n cos 2n pi minus of lower limit e raised to power 0 divided by 1 plus n square minus n cos of 0. So sine is 0 for upper limit as well as lower limit. So we can write here sine 2n pi is 0 as well as sine of 0 is 0. So here bn equal to 1 upon pi as well as here 1 upon 1 plus n square is common. So 1 upon 1 plus n square common term we can take outside. Now e raised to power minus 2 pi. Here this cos term is 1, so remaining is minus n minus e raised to power 0 is 1 and this bracket term here cos of 0 is 1, so it is again minus n. So that means n minus n. Here this minus of minus plus and this is a minus n. So n again you can take common outside. So therefore bn is n upon pi 1 plus n square in bracket 1 minus e raised to power minus 2 pi. Let's suppose this is equation number C. So we know the value of A0, An, Bn. So put A0, An and Bn in equation number 1, that is more formula of Fourier series. So here if we put this value of A0, An, Bn in equation 1, so therefore f of x equal to A0 by 2. So A0, value of A0 is 1 minus e raised to power minus 2 pi by pi divided by 2. A0 by 2. So it is a A0 by 2 means here we take 2. plus summation n varies from 1 to infinity an value of an 1 upon pi in bracket n square plus 1 into 1 minus e raised to the power minus 2 pi into cos nx plus bn is 1 minus e raised to the power minus 2 pi into n divided by pi n square plus 1 into sine nx. If we put the n is 1, 2, 3 in this term, so here we will get f of x is e raised to the power minus x. Here first term 1 minus e raised to the power minus 2 pi upon 2 pi as it is, plus here if we put n is 1, so it is a 1 minus e raised to the power minus 2 pi divided by pi, n is 1, so it is a 1 plus 1 2 into cos x plus 1 minus e raised to the power minus 2 pi, n is 1, so it is pi 2 into sine x. Now next put n is 2, so if we put n is 2, so 1 minus e raised to the power minus 2 pi, n is 2, so it is a 2 square, 4 plus 1, that is 5 pi into cos 2x plus here again put n is 2, so it is a 2 1 minus e raised to the power minus 2 pi upon 5 pi into sine 5 2x. N is 2, so it is 2x. Continue this process up to the infinity. Now here, if we write cos term in one bracket and then sin, so simplified answer of this term is, and here that bracket 1 minus e raised to the power minus 2 pi is common throughout the term it contains. So we can take common term outside as well as divided by pi is contained in each term. So common term if we take outside, so 1 minus e raised to the power minus 2 pi divided by pi is constant common, so we can take outside. Here remaining is 1 upon 2 because this whole term we are taking common, so remaining is 1 upon 2 plus here this term we are taking common, so remaining is 1 upon 2 and into cos x, so we can say it is cos x by 2. Next cos term is here again if we take this bracket divided by pi outside, so remaining is cos 2 pi 2x by 5. If we continue the next term, so you will get cos 3x by 10 and so on. Next for sine, so this is the only for cos term. So plus of sine term is here. From sine, this bracket and divided by pi we are taking common. So remaining is sine divided by 2. So it is a sine x by 2. Next sine term is here. So it is sine 2x by 5. Next term become sine 3x by 10. In this way you will get the next term. So it is a sine 3x by 10 and so on up to the infinity. So this is the Fourier series for e raised to the power minus x. So in this way you have to solve the Fourier series example. In next video we will discuss the next important and interesting question, or you can also share your question in a Telegram group. Thank you for watching.